when we started vertical motion, I showed you this, and I said there's vertical motion where you just let it go, and then there's projectile motion where you give it some horizontal component to its motion. You throw it basically rather than just letting it drop. This next section is all about the projectile motion. And again, I'm going to stick to the convention of having up be positive. It doesn't matter as long as we're consistent. With projectile motion, you give your object that's getting thrown, you give it some horizontal velocity, and then as it falls, it gradually picks up vertical velocity. But if we ignore air resistance, obviously air resistance is going to make a difference here, but ignoring that, the horizontal component of the velocity is going to stay constant. It's going to keep moving horizontally at the same speed. But then as it falls, under free fall, the vertical part of its velocity is going to increase. And it's going to increase according to the normal vertical motion. So basically you have two things happening at once. A constant velocity horizontal motion and a constant acceleration vertical motion. If you take slices of time out of that fall, if you compare it to something that's just dropped, the vertical motion is the same because the only thing affecting the vertical motion is gravity. The horizontal motion moves a constant amount. So each time slice has this, is supposed to, this diagram is not quite right. Each horizontal slice should have the same horizontal distance travelled each time. This diagram isn't quite right. And each time slice has the same vertical position because gravity is pulling it down. Now obviously if you actually threw it up or threw it down rather than directly horizontal, it's going to be slightly different. You're going to have different amounts of this, and it's not going to fall at the same rate. But if you just throw something horizontally or let it go, the vertical motion should be identical. Again, ignoring air resistance. So to solve these kinds of problems, what we're going to do is treat them as separate horizontal and vertical problems. In the horizontal problem, the horizontal velocity is constant. In the vertical problem, the vertical acceleration is 9.8 meters per second downwards. And this is always going to result in parabolic motion. Like this, it's going to come out in a parabola. It's going to come out along a parabola. That's what's always going to happen in a field that has a uniform acceleration. Let me go back here. We're going to treat them as two separate problems, and they're going to be linked by time. That's easier to see when I do some examples. A few words you're going to need to know. Time of flight is the time it takes for whatever the projectile is to actually get to the ground. Range is the horizontal distance from where it was launched to where it hits the ground. And drop is the vertical displacement from where it was launched to where it hits the target.